Okay, so page 2, question number 5, we have to do quadratic regression on this table of values. You can set it up into a matrix and substitute in the values of x and y for to find a, b, and c with a system of 3 equations. But easier, we can do this on Desmos. So I'm going to insert some pictures here and show you. In order to find it on Desmos, you want to look for the plus sign at the top left, and then it'll give you a drop-down menu, and you're looking for the table. So let me show you what that picture looks like. So this is what it's looking for. So we're looking to be able to select table right here. Once we select table, we'll get an X and Y chart, and we can insert all of those X and Y values. All right, so I enter the table of values. So after I've pushed table, I enter the table of values, and it matches the X values here, match the X values here, and the Y values here, match the Y values here. Then we have to put in this special formula, and the special formula looks like this. Y sub 1, and we're using the sub 1 because over here where we have the table of values, we want it to look at this value when it looks for y. So we want it to look at the chart at y sub 1. Tilde is on your keyboard right above the escape key on the top left, or it's on your Desmos graph keyboard as well. And then ax1 quantity squared plus bx1 plus c. And the reason we're using this quadratic equation, or this equation, is because we want the standard form of the quadratic, and ax squared plus bx plus c is the standard form, but we want it to pull, again, from this x1 value. So we want it to use those numbers, 0, 1, 2, 3, and 15, 6, 3, and 6 to plug in for y and x to guess what it thinks the best line of fit for this quadratic equation is. When I do that, I will get this information. So here's what it looks like in Desmos. Again, these x and y values right here are the same x and y values that I put into this chart. Here's that fancy equation with the y1 and the x1. So this guy right here is referring to this guy right here, and these x1s are referring to this x1, and then it tells me an a, b, and a c. So the a, b, and c go into this equation because it asks for the actual quadratic equation. So I'm going to plug it in. Y equals, and a in this case is 3 from here, so 3x squared, plus b is negative 12, so I guess that's actually a minus 12x. And then c is 15, so plus 15. And that would be the equation that it's looking for. Be careful on the common assessment. I don't know if it asks for y equals, or if it already has the y equals and then you have the box to plug in. So make sure this is the final answer. It could also be f of x. You'll just have to look at what it asks for as far as the answer in the final part there. All right, question number 6 asks me to solve the quadratic equation. So in order to solve a quadratic equation, I'm going to make it equal 0 unless I want to use completing the square. This one I can factor, so I'm going to factor it instead. So the first thing I need to do is make it equal 0, so I subtract 14 from both sides. That cancels out over here, so I get x squared plus 5x minus 14 is equal to 0. 5x and 14 are not like terms, so they just stay separated. Now I'm looking for factors of the last term, which are negative 14, and they need to add up to give me 5x, which is the middle term. So I'm looking for things that multiply to give me negative 14 and add to give me 5. Factors of 14, 1 and 14, 2 and 7. Well, I know they have to be opposite signs because of this negative symbol right here. So in order to get a positive 5, that's going to be a positive 7, and a negative 2 gives me a positive 5. Remember, the bigger number over here is going to match the sign of the middle term. So this is going to give me x minus 2 and x plus 7 equals 0. Then the zero product property says that I can make each of these equal 0. So x minus 2 equals 0 and x plus 7 equals 0. So that means that x is 2 or x is negative 7. All I did was add 2 to both sides or subtract 7 from both sides. So those would be my two answers. Now I know somebody's sitting there going, but couldn't you just do this on Desmos? Heck yeah, you can. So you can take this guy and you can graph it just like it is, or you can also subtract it and get it to be this guy right here and look for the zeros. So I'm going to put both of those graphs in here. Okay, let's talk about this first graph here. The first one is the exact same equation that's there. So it's drawing a line through the two solutions. And the two solutions are x equals, we only want the x value, if you remember that from the last topic. When we set these into the Desmos, we only want the x because it's x comma y, and our variable here is x. So we're going to get x equals negative 7 or positive 2. Now let's say instead you just put the x squared plus 5x minus 14 in. You'll still get the same answers. See, I still got negative 7 and 2, but instead of drawing just vertical lines, I'm actually showing the quadratic, the parabola, where it crosses the x-axis, which is where it equals 0, and I'm getting the same thing. X is equal to negative 7 and x is equal to positive 2. So all three are viable solutions for how you could do this problem. All right, gang, so there is an exercise I just did to find the vertex and didn't read the question. So let's make sure we read our questions before we answer them when we're taking our test. The question says, how long will it be before the ball hits the ground? That is a completely different question than how tall or how high does it go. So when it hits the ground, if you can imagine, the parabola looks like this. When it hits the ground is down here when it crosses x equals 0 or y equals 0 when it crosses the x-axis. So I'm looking for where this function h of t is equal to 0. So where is 0 equal to negative 16 t squared plus 64 t plus 80. Now you can do that. You can solve that a lot of ways. I still think that Desmos is a better option here. I just need to know how to interpret this answer. I need to know what does it mean and what is it asking. When I put it in Desmos, Desmos does not like t's. It wants these guys in x's. So make sure you make those an x instead of a t. Otherwise, it'll give you funky answers. All right, so here's what my graph looks like when I stick it into Desmos. The top of the graph might tell me the top height that it reaches, so how far up it actually goes. But it's asking when it hits the ground, and if the y-axis is how high or low it goes, this ball hits the ground when it gets to the x-axis. So it will hit the ground in 5 seconds. That is the x value. It does not matter that there's another x value of -1 because -1 seconds doesn't exist. So our final answer here is 5 seconds. Again, be careful here because there are other questions that ask me how tall or how high up the ball goes when I throw it into the air. So this one is a different type of question. So make sure you're reading what the question's asking. Okay, this one is exclusively a Desmos type of question. We need to know the interval on which the function is negative. Now, I don't know if they're going to ask for it in interval notation. You know, that's with the bracket dealies and the parentheses and the infinities and negative infinity things, or if it's going to be a y is less than or greater than kind of thing, x is less than greater than kind of thing. So you'll have to look and see what the question asks for when you take the actual test. So let's check out the graph first. X squared minus 3x minus 4. All right, so here's what my graph looks like. It's asking for where it's negative. So it's asking for the negative part of the graph. The negative part of the graph is anything that is below the x-axis. So that's all the stuff down here. So I could write this in interval notation, and I would say that it's between the x values of -1 and +4. It will not include those numbers because on the number -1 and on the number 4 it will be neither negative nor positive because it's actually on the line. So it would be in parentheses, -1, comma 4. However, it could be set up so that you have to fill in the blanks of the x values with less than or equal to, greater than or equal to symbols. And so we would look at it and it would be -1 has to be, x has to be bigger than -1, but it has to be smaller than 4. There would be no equal to signs because, again, it's like that parentheses. It doesn't include the numbers -1 and 4. If it asked for the positive interval, which it does not, so if you're still listening, the positive interval is completely opposite of what I'm going to say next. The positive interval will be the side that's above the x-axis. That's where you'll get your infinities. So if I were going to write it in interval notation for the positive interval, positive would be from -infinity up to -1, and then it would be from 4 to positive infinity. Or it would be x is less than -1, but x is greater than positive 4. This is only for positive. This is positive. My actual question asks for negatives. This is the negative answer. I don't know what the question asks on the test, so know how to do both of those. All right, this guy's pretty easy. We're solving it over complex numbers. So remember, in a complex number, the square root of -1 is equal to I. And so when I write this, x squared is equal to -49, I start by taking the square root of both sides. That's the inverse of squaring something. And so I get that x is equal to, well, this guy I have got to break up. This is 49 and -1. I know the square root of 49 is plus or -7, and the square root of -1, I just told you guys, is I. You do need to have that plus or minus. If you lose that plus or minus, it's going to tell you you're wrong. So make sure you put the plus or minus because both answers are correct. All right, these are fun. These are our double distributing properties. We are so good at the distributive property, you guys. This is no different. So we take our 9 and we distribute it. Don't draw all your rainbow lines all at the beginning. Do them as you go. So 9 times 9 is 81. 9 times -I is -9i. I times 9, so now I'm going to go back in. Let's grab a different color. Now I'm going to take this guy and distribute it. I times 9 is positive 9i. And I times -I is -I squared. So these two guys cancel out. -9 and positive 9 cancel out. So I get 81 minus I squared. Well, remember, the square root of -1 is I, which means that if I were to go and square both sides, that I would get -1 is equal to I squared. So that means I can substitute this I squared with this -1. So that means that I end up with 81 minus, let's write that again, 81 minus a -1. Well, a negative and a negative, they make a positive. So I get 82 is my answer. If I have a binomials like this, where one is positive and one is negative, and they're the same otherwise, those inner and outer terms, that -9 and positive 9i, will always cancel. Okay, this is where we have to multiply by the conjugate. This one is very tedious, but none of the parts are super difficult. So I have 8 over 1 plus I. Remember, the conjugate is just the opposite imaginary term. So we just changed the sign on the imaginary term. So I'm going to multiply by 1 minus I, and I'm going to do it on top and bottom. My rationale is that anything divided by itself is 1, so I'm not actually changing anything by multiplying by 1 minus I over 1 minus I. I'm essentially multiplying by 1. It's just a super fancy version of 1 so that I can get something cool to happen. So here's the cool thing that happens. When I take that 8 and distribute it, we distribute like normal. So we get 8 minus, do it again, 8i. Nothing super fancy there. Because these are, one is the complex conjugate of the other, when I do the same thing in the denominator, my middle terms are going to cancel like that last question we did. So I'm going to get 1 times 1 is 1. 1 times -I is -I. Then on the other one, I'm going to take my I and distribute. I times 1 is positive I, and I times -I is -I squared. So then we go to simplify. Don't get overwhelmed. Just do it in pieces. The top is fine. 8 minus 8i, ain't no thing. On the bottom, these guys cancel, and I get 1 minus I squared. But remember, because we did that little fanciness, -1 is equal to I. If we square it, we get that -1 is equal to I squared. And so that I squared can turn into a -1. So I have 8 minus 8i over 1 minus -1. 1 minus -1 is the same thing as 2. So I'm looking at 8 minus 8i all over 2. Well, 8, 8, and 2 are all divisible by 2. So I'm going to chop them in half. I'm going to go chop, chop, chop. Chop, 4. Chop, 4. Chop, 1. 8 divided by 2, 4. 8 divided by 2, 4. 2 divided by 2, 1. I divided everything by the same thing, which was 2. So this turns into 4 minus 4i. I don't have to put the over 1, and Savas is not going to like you to put it over 1, so leave it as 4 minus 4i. That's all for page 2. I'll do another video for page 3.